creating equivalent fractions. So before we get into talking about creating equivalent fractions and learning the strategy that we're going to be using during this unit, let's talk just for a moment again about understanding fractions. For example, with 2/8, if you see the numerator 2, this is the top number, and it represents either the parts that we have, or it could represent what we're missing. It depends on the story that the fraction goes along with. The denominator, 8, the bottom number in the fraction, represents all of the parts, or the whole group. When talking about the creating equivalent fraction strategy, this is just an easy way to create equivalent fractions, practice our multiplication facts, and ensure that we're using the least or lowest common denominator in an equation. This is going to be important because as we get into adding and subtracting fractions with unlike denominators, we're going to have to go from unlike denominators to like denominators. And we're going to use this strategy to help us find those common or like denominators. So here's the first example. I'm going to start with the fraction 1/2. And as I am building this kind of fact bank in a way of equivalent fractions, I'm going to set up kind of a framework of how I'm going to create these fractions. Now, recognize that when I'm doing this, or when your student is doing this, every equivalent fraction that we create is going back to 1/2 again. It's comparing all the other fractions back to 1/2, which is the fraction that we're starting with. So to do this, we're going to start by skip counting or multiplying by our ones. We're starting with the numerator 1. So we're just simply going to count, in this case, 1, 2, 3, 4, 5. So there are the next 4 numerators in our sequence of equivalent fractions. I'm going to do the exact same thing with the denominator 2. I'm going to start skip counting or multiplying by 2. 2, 4, 6, 8, 10. This is listing your multiples of 2. And now you can see that each fraction that we've written out, 2/4, 3/6, 4/8, 5/10, are all equivalent to 1/2. Let's take a look at another example. I'm going to do the exact same thing as I did with 1/2, but this time my fraction is 7/8. So now I'm going to practice listing my multiples of 7 and my multiples of 8. So I'm practicing my multiplication facts and creating some equivalent fractions. So I'll start with the numerator 7. I'll count by 7. 7, 14, 21, 28. Then I'll count by my denominator 8. 8, 16, 24, 32. All the other fractions that I have listed, 14 16ths, 21 24ths, and 28/32, these fractions are all equivalent to 7/8. And if ever you want to check yourself, you can simply pull out 7/8 and one of the other fractions. I'm going to choose 28/32 and just check to make sure, did you create an equivalent fraction? Well, I know that 7 times 4 is 28. I know that 8 times 4 is 32. Since I've multiplied both the numerator and denominator by the same number, in this case 4, this has given me an equivalent fraction of 28 over 32. So what does that mean, or what does that look like when we are actually working with adding fractions with unlike denominators? So what I've done is I've set up the equation 1/2 plus 7/8. So I'm going to come back in and I'm going to start out with my first fraction from my equation, 1/2. I've written it first so that I can ensure that when I go to replace these fractions with their equivalents, then I put the correct fraction in the correct place in my equation. So I start with 1/2. Again, I'm going to be skip counting or listing my multiples of both the numerator and the denominator in each fraction. So I'll start with 1/2. I will list out and go 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. Then I will come down to 7/8, 7, 14, 21, 8, 16, and 24. Now, as you can see, I have a bunch of fractions that look a little daunting, but what I want to do, my ultimate goal is I want to find the two denominators that match in both lists. So I'm going to compare the two lists, and I'm looking for denominators that match. So if I look, I'll start with the 2 here, and I notice I don't have anything in the list below that has 2 as the denominator. I don't have anything that is 4, so those 2 are eliminated so far. In the list below, I have no denominators that are 6, so that's not a match. But then I look at the denominator 8 in 4/8. I can see, starting with the very first fraction that I started with, it below 7/8, there is the denominator 8 as my original fraction. In this case, I can actually use one of my original fractions in my new equation. So I'm going to circle 4/8, and I'm going to circle 7/8. What will end up happening as we begin adding and subtracting fractions with unlike denominators is then we will come in below the original equation. I'm going to move my equation just because I did not give myself enough room to work, so I'm going to move it down here a little bit. And then I'm going to replace 1/2. And just below 1/2, I'm going to write my new fraction that's equivalent to 1/2. I'm going to write 4/8. Then I'm going to come in, and because I recognized that I can continue using my original fraction 7/8 because the denominators match, I will just rewrite 7/8. Now I can add these two fractions together because they both have 8 as the denominator. So when I add, I only add the numerators together. The denominator will stay the same. So I have 4 plus 7 is 11, and then 8 is my denominator. So I have the answer 11/8 is the sum of 4/8 plus 7/8. It is also the sum of 1/2 plus 7/8.